Hello friends, Prerna this side from iNeuron. Welcome back to all of you. So here we are with a new topic, that is sequence and series. First of all, this chapter is very important in terms of board exams and any JEE preparation also. Okay. And the second thing is, this chapter contains very less concept. So it will be easier to understand this chapter and solve the question of this chapter. Okay. Now, what is sequence and series? What is sequence? Ordered list of objects or numbers or anything. Okay. So, ordered list of objects is called sequence. Okay, let us take an example. Let us take an example that you have 100 rupees. Okay, you have 100 rupees and you want to deposit 10 rupees every day. So it will be like, in the next day you have 110, then 120, then 130, and it goes on like this. Okay, now you can see that this sequence follows a certain pattern. Okay, so they are ordered. Every next number is 10 more than the previous number, isn't it? So it is following a pattern. You cannot replace second term with third or third with second, or first with second and second with first. Okay, so that is why it is ordered list of object, which is called as sequence. Okay, let us suppose that you have 50, your weight is 50 kg. Okay, I'm sorry, your weight is 50 kg and you want to reduce it by 3 kg every month. Okay, so the sequence should be 50, 47, okay, like this. So you can see again this sequence is following an order. It is a pattern. Okay, every time we are decreasing 3 kg. So in this sequence also we cannot replace any two consecutive terms. Every term is identified, isn't it? So this is the basic funda of sequence. What is sequence? In simple words, it is ordered list of objects which are ordered. Okay, let us go through the definition. The definition is, the word sequence is used in much the same way as it is in ordinary English. When we say that a collection of objects is listed in a sequence, we usually mean that the collection is ordered in such a way that it has an identified first member, second member, third member, and so on. Got it? Now, a sequence is an arrangement of any object or a set of number in a particular order followed by some rule. So whatever be the sequence, it can be increasing, it can be decreasing, it can be in the manner of addition, adding a constant every time, or multiplying a constant every time. Okay, so order can be anything, but it will be followed. Okay, it will be followed throughout the sequence. So what it says, sequence is an arrangement of any object or set of number in a particular order followed by some rule. The rule can be of addition, multiplication, division, anything. Okay, now moving on to next, it says a sequence containing finite number of terms is called a finite sequence. What does it mean? If you have a sequence and it ends like this, so you know that there are 5 numbers in the sequence, so it is a finite sequence. Similarly, a sequence is called infinite if it is not a finite sequence. Like if it says that it is 1, 2, 3 and goes on like this, so it is not ending at a certain point, so it is infinite. Got it? Now, there is one more thing, that is Fibonacci numbers. Fibonacci numbers form an interesting sequence of number in which each element is obtained by adding two preceding elements. Let us suppose that first element is 1 and second is 1, and the third will be sum of these two preceding terms. So it is a1 plus a2, that is 1 plus 1, 2. So this will be rarely used in the chapter. So the basic thing is, you have to understand what is sequence and what are finite and infinite sequences. Got it? Moving on to next. Now the next topic is progression. it is not necessary that the terms of a sequence always follow a certain pattern. So we have taken the example in which the sequence is following a certain pattern, but it is not necessary that always sequence will follow a certain pattern, or they are described by some explicit formula for the nth term. Those sequence whose term follow certain pattern are called progression. Okay, so not every sequence will follow a pattern, but those sequence which follow a pattern are called progression. Okay, you have heard about arithmetic progression, isn't it? Why? Because we used to add or subtract something with every successive elements. Now the next point is series. Let a1, a2, a3, a and b a given sequence. Let us suppose you have a sequence. Let us suppose you have a sequence 2, 4, 6, 8. Okay. Then the expression, this a1 plus a2 plus a3 till an is called the series. It can be called as series associated with the given sequence. The series is finite or infinite according to the given sequence is finite or infinite. Now if it is a sequence and you want to write a series for this sequence, then what you will do, you will write just like this. You will put plus sign in place of commas. Okay, got it. So this is sequence and this is corresponding series. If sequence is infinite, then series is also infinite. If sequence is finite, then series is also okay. Now let us suppose that if I'll say that there is a sequence having 4 elements only, so it is a finite sequence and corresponding series will be 2 plus 4 plus 6 plus 8. So if someone asks what is the series for this given sequence, then you will write 2 plus 4 plus 6 plus 8, but you cannot write the sum of all these 4. You cannot write that series is 20. You cannot write this. Series is this. You cannot add them. If I'll say that sum of the series, any series, then you can add these things. Okay, then you can add these things. But actually, when it says only series, you can write the terms with a positive sign in place of comma, but you cannot add them. If the question says sum of the series, then only you can add the elements of given series. Got it? Okay, moving on to next slide. This is types of sequence and series. Some of the most common example of sequences are arithmetic sequences, geometric sequences, harmonic sequences. So this is not in our syllabus, so we will not discuss about it right now. Okay, we will discuss about it later. So arithmetic sequence, you are familiar with this. In this sequence, the terms will follow a certain pattern in which some constant will be added with each successive element or subtracted. Okay, geometric sequences, some constant will be multiplied. So we will add something in this and we will multiply something in this. This is the only difference between these two sequences, and formulas are obviously different. Now let us start with the arithmetic progression. We know about this topic, still we will memorize it for solving question of class 11. Now an arithmetic progression is a sequence where the difference between every two consecutive terms are the same. If you remember from class 10, there is an AP like 2, 6, 10, 14. So difference of any two consecutive term is always same. 6 minus 2 is 4, 10 minus 6 is 4, 14 minus 10 is again 4. Okay, so for example, the sequence 2, 6, 10, 14 is an arithmetic progression because it follows a pattern where each number is obtained by adding 4 to its previous term, isn't it? In the sequence, nth term is 4n minus 2. You can find out this thing using the formula if you remember. Right now, let us consider this is the formula for this given sequence. Okay, the terms of the sequence can be obtained by substituting n is equal to 1, 2, 3 in the nth term. Now if I'll put the value of n as 1, 2, 3, it will give first, second and third term. If I'll put the value of n as 1, it will give 4 into 1 minus 2, that is 4 minus 2, 2. So this is the first term, isn't it? Similarly, if I'll say 4 into 2 minus 2, Okay, so it is 6. 8 minus 2, 6. This is the second term. So in this formula, if I'll put the value of n as 1, 2, 3, it will give first term, second term, third term, and so on. Okay, the general form of an arithmetic progression is this. If you remember that in the standard 10, we used to consider 3 terms in an AP. When the question says that sum of 3 terms is this and product of these 3 terms is this, then we used to consider that let the 3 terms be a minus d, a and a plus d. So, okay, now these 3 things are actually in AP because we can find the common difference and check it. Like if it says that you have to find the common difference, that is second minus first. Second minus first. So it will give a minus a plus d. So it is nothing but d. Similarly, if I subtract second term from third term, it will again give d. So this is a AP. Now the general term of the general term or nth term of an AP whose first term is a and the common difference is d is found by the formula a n is. We simply write it in a small a plus n minus 1d. Now what is a? A is actually first term. Okay, a is actually first term, n is the nth term, which term you need to find, or the term which is given, and d is common difference. Got it? So this is the basic formula of arithmetic progression. We are familiar with these things. Let's move on to next topic, that is geometric progression. Before that, I need to tell you something. Arithmetic progression can be of 3 types. It can be increasing. It can be decreasing. We know about these 2 things. And it can be a constant. Like, if I'll say about increasing AP, so it will be 2, 4, 6, 8. So it is increasing since we are adding 2 every time, isn't it? Now it can be decreasing. It can be 10, 8, 6. So what we are doing? We are subtracting 2 every time. Now if I'll say that there is a AP 2, 2, 2, 2. Now we can question it that how it is an AP. If I want to find the common difference, that is second minus first, it will give 0. Third minus second, it will again give 0. Fourth minus third, it will give 0 again. So every time we are getting the same common difference. So this is also an AP. Got it? So this is also an AP. Okay. Why? Since it is following the rule of AP. Following the rule of AP. Every time we have the same common difference, and if common difference is same, then it is an AP. Okay. So the next topic is, and the last topic is geometric progression. A geometric progression, also known as a geometric sequence, is a sequence of non-zero number. So non-zero number where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. So here we have common ratio, not common difference. Okay, for example, the sequence 2, 6, 18, 54 is a geometric progression with common ratio 1 by 2. The nth term of a geometric sequence with initial value a and common ratio r is given by an is equal to a r n minus 1. So if I'll write it in small letters, it is a n a r n minus 1. Now what is a? A is again a first term, as we know. First term. Okay, what is r? R is nothing but ratio of 2 consecutive terms. R is actually second by first, or it can be third by second, it can be fourth by third, any 2 consecutive terms. Okay, so this is the R common ratio by which we are multiplying each term to get second number. Like it is 10 and it is 5. So if I want to write the value of common ratio, it will be 5 by 10. So it is nothing but 0.5. So every time we are multiplying by 0.5. Okay, so it is a geometric sequence with common ratio 1 by 2. Nth term is this. The general form of geometric sequence is AR square. So we are multiplying R every time with the previous one. Where R is not equal to 0 is common ratio. R cannot be a 0. It is a non-zero number. Okay. If R comes 0, then it is not a GP. Okay. So these are some basic concept of AP and GP. Now what we will do, we will discuss one by one. In the next video, we are going to discuss NCERT question of sequence in series. After that, we will move on to AP and then GP. Okay. So in the next video, we are going to discuss first exercise of sequence and series. Okay. So till then, bye bye.